In this video, we're going to do an example using double angle formulas. Specifically, we're going to determine the values of sine 2 theta, cos 2 theta, and tan 2 theta if we know that the tan of theta is equal to negative 12 over 5. Well, before we get too far into this question, a very important part of this question is right here. That part is telling us that pi over 2, and if it helps you, think of that as 90 degrees, is less than theta is less than pi. If it helps you, that's 180 degrees. 90 degrees is here and 180 degrees is here. What that tells us is we've got a terminal arm over in the second quadrant. In the second quadrant, x is always negative and y is always positive. And you might remember we have a lot of formulas for trigonometric functions. The three primary ones, sine theta equals y over r, cos theta equals x over r, and tan theta equals y over x. In those expressions, r is always positive. Okay? And so what we're going to do now, and another formula says that r squared equals x squared plus y squared. So what we're going to do now is we're going to say, okay, tan theta equals negative 12 over 5. That means that y over x equals negative 12 over 5. So on first glance, you might say, okay, therefore y equals negative 12 and x equals 5. That's a good way to think of it preliminarily, but remember we just said y has to be positive and x has to be negative because of where we are. So that means, therefore, we're going to say y is 12 and x is negative 5. After that, we're going to find the value for r by using the formula r squared equals x squared plus y squared. And then when we find out what r equals, we're going to have values for sine theta, cos theta, and tan theta, and we're going to be able to find all of these values. So that's an overview of the solution that we're about to do. So we start going back to the beginning. We know that sine theta is in quadrant 2. Again, repeating this part right here. So x is negative and y is positive. Tan theta equals y over x. So for the reasons we said earlier, x is negative, y is positive. X is negative 5, y is 12. Using the formula r squared equals x squared plus y squared, we ultimately find that r squared equals 169. R is therefore the positive square root of 169 because it has to be positive, and is therefore 13. So we can say that sine theta is 12 over 13, cos theta is negative 5 over 13, and tan theta is negative 12 over 5. Awesome. Well, the sine of 2 theta is going to equal 2 sine theta cos theta, and all we have to do now is plug the appropriate values here into that equation, into that expression, and we've got our answer. So 2 times 12/13 times negative 5/13 ultimately equals negative 120 over 169. That's what sine 2 theta equals, and we've answered the first part of the question. Well, how about cos 2 theta? Cos 2 theta, as we know, is cos squared theta minus sine squared theta. Cos squared theta can be thought of as cos theta quantity squared, and sine squared theta can be thought of as sine theta quantity squared. And so we plug in our value for cos theta, which is negative 5 over 13, plug in our value for sine theta, which is 12 over 13. When we do that, we ultimately get a value for cos 2 theta of negative 119 over 169. Okay? Now you might be tempted to say, wait a second, you're telling me cos 2 theta is cos squared theta minus sine squared theta. Why didn't you use cos 2 theta equals 2 cos squared theta minus 1? Or why didn't you use cos 2 theta equals 1 minus 2 sine squared theta? And the short answer is we could have used any of them. If we do it correctly, we'll get the same answer no matter which one of those formulas we use. Now we're going to get tan 2 theta here. Two ways of doing that. Tan 2 theta is equal to sine 2 theta over cos 2 theta. Okay, sine over cos is tan so long as the angles are the same. We already figured out that the sine of 2 theta is negative 120 over 169. The cos of 2 theta is negative 119 over 169. So we have fraction divided by fraction. We're going to invert and multiply and ultimately get 120 over 119. That's what the tan of 2 theta equals. Now you might say, well, why don't we use the double angle formula for tan? We can. If we want to use the double angle formula for tan, then we remember that tan theta is equal to negative 12 over 5. So we have 2 times negative 12 over 5 in the numerator, and 1 minus negative 12 over 5 quantity squared in the denominator. 2 times negative 12 over 5 is negative 24 over 5. Negative 12 over 5 quantity squared is 144 over 25. So now what we have in the denominator is a situation that calls for a common denominator in the denominator. So 1 is 25 over 25. And ultimately we get negative 24 over 5 over negative 119 over 25. Okay, that is what tan of 2 theta equals. But obviously we need to simplify that. So we come up here, we invert and multiply. When you have a fraction times a fraction like this, the denominator has a factor of 5, and this numerator has a factor of 5. So that gives us this expression right here, which is negative 120 over negative 119, which is 120 over 119. And we can make a very beautiful therefore statement giving all 3 requested values. And we're going to go through the rest of these questions in later slides.